Alright, so let's get started. Let's define simulation first. As we know already, that simulation is the imitation of the operation of real world process or system over time. Here I would like to add that this real world process or system could be your, let's say, a bank example or an industry or anything, right? And in order to make a model which will mimic my real system, I will be required to collect data, and I will be making decisions on the basis of that collected data. Or in other words, we could say that the data collected will serve as an input to that model. The behavior of the system is that evolves over time is studied by developing a simulation model, and we would like to know that how my system will behave in future given that I provide it some data, right? And then I can represent my model or express my model with mathematical logics or by some symbolic relation between the entities which are present in my system. And I would like to add that whenever you are making a model, you like a simulation model, you need to know what are your assumptions. You need to predefine that. Uh, let's talk about the goals of modeling and simulation. So, a model can be used to investigate a wide variety of what if related question about the real world. So, what if related questions are kind of part of sensitivity analysis, and in various scenario, we would like to know that how my system will behave if I am changing various parameters. In addition, simulation can be used also to predict the effects of changes and design tool to predicate the performance of new system. Uh, as manufacturing cost is way more than a computer simulation model, so it's a very good idea to perform simulation analysis before you want to implement the system. Like I gave you example of a water turbine. So it's a very good idea to make a small prototype of that before you go for the real product. Uh, Simulation is a very powerful tool and it can be very useful, but it's not always useful. So let's talk about when it is appropriate to use simulation and when it is not appropriate to use simulation tool. So let's start with when simulation is appropriate, right? So the first one would be simulation enables the study of internal interaction of a subsystem with complex system. And in simulation we know that how the subparts or subsystem is interacting. I'm talking about interaction. Second one is the informational, organizational, and environmental changes can be simulated and find their effects. So in an organization, we would like to know that okay, if I do some kind of changes, right, how will it affect my system? So that is the key. And if you're doing simulation for the subsystems, you would like to know that okay, if I'm adding a small subsystem to my complex system, what is the effect of that small system on my large or complex system. So that's why simulation is a very, very helpful tool in this regard. And when we are working on simulation, so we can gain knowledge about the real system, because we need to study that system before I need a simulation model for it. So in other ways we can say that, okay, simulation model is helping us to gain more knowledge about my real world system. And then if I can, like, find important input parameters with changing simulation in, and because we have gained knowledge about the real system, so it's kind of helping us in identifying those inputs which are important. On top of that, it's also giving, or we could like easily identify the interaction of those important inputs or variables or parameters of the system. Simulation can be used with new designs and policies before implementation, definitely, because if you are implementing something, it will definitely require a lot of money and time, stuff like this. And definitely simulation can also help us in determining the different capabilities of a machine, and like what is the throughput, what is the utilization of a machine, and at what particular levels I need to run that machine to get the best out of it. So simulation can definitely help us in that one. And definitely the simulation model designed for training purposes are less costly than the real world systems, because simulated models are cheaper. On top of that, a plan can be easily visualized with the help of animated simulation, instead of basically going to that place. Going to that place might involve a lot of time, a lot of cost, maybe resources are not available. And in like nowadays systems are extremely complex and large, so factory, water fabrication plants, service organizations, such systems are extremely complex, and their interaction can be only treated by simulation. On top of that, giving you example of machine failures, so if you want to model maintenance time or machine failures, so it's a very good idea to use a simulation model, and that will give you a better understanding, or better estimates for that. Giving you example of complex system modeling, uh, we modeled KTH hospital, different various departments utilization, and what is usually the service time for patients, and uh, what is the waiting time, what is the maximum queue length we could be expecting, because they needed some recommendations that we have some space available and we would like to build new departments, um, given that we which one are overcrowded. On top of that, they also ask for a layout which will minimize the distance traveled by the patient. So we already have a paper on that particular topic if you want to read about it. So look it up online. Let's talk about when simulation is not appropriate. So first, when the problem can be solved by common sense. So if you could like solve it by reflex action or by just logic, simple logic, then no need to build a simulation model for that. Mm, and when the problem can be solved by analytical methods easily, where then you don't need to set up a simulation model. Third one would be if it is easier to perform direct experiments and data collection is extremely easy, not expensive at all, then instead on top of that also not time consuming. So it's a very good idea to just value take values from direct experiments rather than building a simulation model. If cost exceeded saving, so definitely it's not wise to spend so much money on simulation model. Definitely if you don't have resources or time, then you cannot make simulation model. um, Last one, we could say, okay, if the system behavior is too complex, such as human behavior, then there are so many parameters involved that you cannot um, do simulation for that. So then it's not a very good idea to deploy or use simulation in such scenarios which we discussed. Mm, Here I would like to add something, that if no data is available about the real world system, right, then it's very difficult to set up your simulation process or make your simulation model. And in addition to that, you don't have any idea that what sort of output you will be getting. So really in simulation, data is extremely important. Let's talk about advantages and disadvantages of simulation. So, in contrast to optimization models, simulation models are basically run rather than solved, and they are basically different iterations or replications, and they are run uh, for the whole uncertain region.